Welcome back, barbarians. It has been quite a while. The game is called Time Barbarian, and at least part of the reason that we went with that name is because it included a time freeze mechanic or bullet time mechanic. And you know, if that's the name of the game, it's got to have that feature. I've finally gotten around to implementing that, and I did run into some unexpected pitfalls doing that in Unity, and let me show you some highlights of what I discovered. First, let me just show you the mechanic. I've got it rigged up here, the P button, I just have it rigged to pump up, there you go, to pump up my time bar, and I implemented it with the Snail. I just made the Snail be the button that you hit to activate it, and that causes enemies to go into slow motion. Let's fill it back up. Okay. Let's take a quick look at how I implemented that. I have a new class called BulletTime, and using my favorite self-instantiating singleton pattern, I made it so that you can get the bullet time at any point by calling the public static getter function. And you'll see here that I've used the feature where if it does not already exist, one is loaded out of the resources folder. And loading the object out of the resources folder is how I was able to attach public variables to it. In this case, I'm using that to attach to sound files to my object. And in the update is a little trick in here. The core of all of this is I am using Unity's Time.timeScale feature. TimeScale is a built-in bullet time mechanic that just allows you to go into slow motion or fast motion just by changing that on a scale. If you put timescale equals 1, you get normal speed. Timescale equals 0 is complete stop. So we're going to go into a bullet time where time slows to either 10% normal speed or actually 5% normal speed. There's two modes of bullet time. It's like regular bullet time and there's super bullet time. Okay, and so what I'm going to be showing here is just timescale is going to go to 0.1. That's going to slow the game down. The little trick that I'm applying here is that when you kick in bullet time, it turns on. Everything stops. But as the bullet time starts to run out, I have a short amount of time where it ramps out. And so when you push the time slow button, everything sort of just stops, and then it's moving real slow, and then it accelerates out as opposed to just snapping back to full time. It's going to ramp out at full time. That creates a nice little transition and adds, I think it adds something to the mechanic. And so that's why this is a little bit more complex. I'm going to activate bullet time. And then you can maybe notice that as the bullet time wraps up, the missiles and stuff accelerate back out towards me. There are a few different paradigms for bullet time in video games. On the one hand, perhaps we would freeze time or slow time for the enemies and the player equally, and that would mean, you know, all motions are slowed down, bullets are slowed down, but this gives the human player an opportunity to have better reaction time, to think more clearly and move more precisely. And so that's, you know, like in Max Payne, that's what you'd see. In other games, we will slow down everything except the player avatar. The player avatar then can zip through the frozen world. And that's what we're doing here in Time Barbarian. I've also experimented with sort of a hybrid. The idea of bullet time really comes from the Matrix movies. And if you watch those movies, you'll see that the main character, when bullet time begins, the main character moves slowly, but they're still moving at many multiples the speed of the bullet. So they're able to dodge bullets not because of just increased reaction time, but the time difference is significant. So bullets slow down to a crawl, and the human beings slow down, but just not as much. We use that in Shrek 2, for example, for the bullet time effect in that. And I experimented with that here in Time Barbarian. Lucky for me, where we resolved for Time Barbarian is that the enemies will slow down, but the player remains at full speed. And I say that's lucky because doing anything other than that in Unity is quite complicated. Unity gives us this time scale, but there's only one of those. So everything that's using time.delta-time will be scaled equally by this bullet time. So if we wanted to do the max pain approach, that's very trivial to use. We just use that. However, if we want to do what we're doing here, which is that the player goes at full speed and the enemies are slowed down, then all we really have to do is make sure that the player's update code is using unscaled delta time as opposed to delta time. And that brings us then to the bullet class. The bullet class is shared by player bullets and enemy bullets, and so we now need a parameter that lets us decide, is this a player bullet or not? And if it's a player bullet, we'll use unscaled time. But if it's an enemy bullet, we'll use delta time. And so that'll get us most of the way. If we wanted to do the Shrek approach where the player is not using that but something else, then there would be some logic required here. Just a multiply. You just need a multiplier on here, and that will get all of that done. But the difficult part would emerge in the animation updates. Let's take a look at the animation updates and see those in action. Let's look at my little penguin wings flapping, but now they're all slowed down, right? And we don't want that. We don't want the player's animations to be affected by bullet time. So that means we are going to have to go into the player animation settings. It's a prefab, so I'm going to open that prefab. Here's the player itself, and it has a sprite renderer with an animator on it. And all we have to do is change the update mode to unscaled time. Luckily, Unity gives us that option right there on the animators. If we wanted to do two different scales, we'd have to get fancier with this, and we'd have to add a script to manually control the playback speed of the animator. And then I have some other things on here. I have the egg shield. Egg shield also is only for the player, and the missile launcher. Missile launcher. Here we go. Unscaled. And the missile does not have an animation on it. The bullets that the player shoots, some of those are animated, and the player's missiles. But I've already done that. Let's pump that thing up. Okay. Now when I engage bullet time, the player's animations move at full speed. You might have noticed another bug, and this is the one that I really want to highlight today. If I line up an enemy and I shoot him, sometimes the bullet goes right through. Let me just rewind that and show you again. The bullet goes right through. Why is that? It took me quite a while to try to diagnose exactly what was causing that. And what I have discovered is that I'm using 2D physics to detect the collisions between the bullets and the objects, and the physics system runs at a separate tick rate than update. You may have noticed this before in Unity. There's the update and there's the fixed update, and the physics usually runs on the fixed update. And apparently, when you adjust the time scale, that affects the rate at which physics ticks. And so now my bullets, which are moving at unscaled time, are moving 10 times faster than they are updating in the physics. The physics is only updating 1/10. The physics is apparently updating at 1/10 the correct rate because that is affected by time, the time scale. Yeah, and if anyone from Unity is watching, that's a bug. That is not correct. Physics should not update less frequently. The time scale of the update maybe could make some sense, but no. So there's a fix for that. We can go in here to the project settings, and I'm using physics 2D. So the 2D physics right here, the default is simulation mode on fixed update. We're going to move that to update. So now the simulation will tick during the same update cycle. And that should solve our problem. Oops. Okay, here we go. Line up. Every shot now makes contact. Okay, so that is time freeze. It's got the basic implementations in here. I haven't done the shaders yet. In the original game, there was a shader effect that went over here, and I do think something like that is really required to highlight the fact that you're in time freeze mode, and a few other little bits and bobs to just button the whole thing up. But that I found really interesting, particularly the fact that the update rate of the physics system was affected by the time scale, and a workaround that I found for it. Hopefully that workaround can work for you as well if you're running into that same problem. So that's it for the devlog today. Until next time, I'll see you out there.